Welcome to the Explainer. So, we live on this magnificent blue planet, a giant marble of swirling oceans. Yet underneath all that blue exterior lies a fundamental, almost unbelievable irony regarding our most vital resource. Today, we are unpacking one of the most urgent puzzles of our time. We're going to make the science behind it completely clear without skipping over any of the crucial details you need to know.
Now think about this. If 3/4 of the Earth's surface is covered with water, how is it mathematically possible that by the year 2025, an estimated 2 billion people will live in absolute water scarcity? It sounds like a total contradiction, doesn't it? Let's unpack exactly why this is happening and what it means for our future.
Okay, let's dive into this. Here is our roadmap for today. We'll start by defining the Great Water Paradox, explore the causes of scarcity, examine the crisis of water quality, compare dams and megaprojects with traditional rainwater harvesting, and finally, look at securing our water future.
Section 1. The Great Water Paradox. Fresh water is constantly renewed and recharged through the hydrological cycle. It evaporates, it rains, it flows, and it repeats. So why the shortage? Well, it's because scarcity is totally dependent on space and time. When we hear the phrase water scarcity, we instantly picture arid regions, like women walking miles for a single earthen pot of water in Rajasthan. But look at the stark contrast here. You can have a Kashmiri earthquake survivor carrying water through heavy snow. It's wild, right? Scarcity isn't just about hot deserts, it's about seasonal variations and annual precipitation. You can have plenty of water during the monsoon, but face a severe crisis when the dry summer months hit. It literally happens across all different climates.
Moving on to Section 2. Causes of water scarcity.
Nature is really only half the story here. The rest is entirely on us. We've got three primary culprits that are deeply tied to modern life. First up, agriculture. To feed our massive population, farmers are heavily pumping groundwater for dry season crops, which dangerously depletes the water table. Then there's industrialization. Heavy industries and multinational corporations demand absolutely massive amounts of water for manufacturing and hydroelectric power. And third, urbanization. As our cities multiply and get denser, individual housing societies just install their own private groundwater pumps. It's your classic tragedy of the commons. Everyone is independently draining the exact same fragile shared resource until it simply runs dry.
Section 3. The crisis of water quality.
Up to this point, we've focused heavily on sheer volume. But what if you have plenty of water and you still can't use it? It brings to mind that famous phrase, water, water everywhere, nor any drop to drink. It is entirely possible for your local region to have an abundant volume of water, yet still suffer from absolute scarcity simply because of a severe degradation in quality.
Now, what's really interesting here is how perfectly this captures the sheer irony of the crisis. Imagine a massive flood where a young boy is attempting to collect drinking water. Life in a huge city like Calcutta can be completely paralyzed by a record 180 millimeters of incessant overnight rain. Literally, there is water absolutely everywhere in this environment. Yet, because those floodwaters are thoroughly contaminated, access to safe, clean drinking water is actually ruined. This pollution is what we call the invisible threat. Even when our rivers are full to the brim, they are often rendered completely hazardous for human use by untreated domestic and industrial wastes. In agriculture, a heavy reliance on chemical fertilizers and pesticides means those toxins seep right back into the earth, draining directly into the very groundwater we rely on. So the scarcity isn't always because the well is dry. Sometimes the scarcity exists because the well is poisoned.
Sections 4 and 5, Dams and Megaprojects versus Traditional Rainwater Harvesting.
So how do we actually fix this? Historically and recently, humanity has tried two very different paths. On one hand, we have massive modern engineering, multi-purpose river projects. We're talking giant dams that control floods, generate hydroelectricity, and provide large-scale irrigation. But they alter natural river flows and can cause serious ecological issues like soil salinization from over-irrigation. On the other hand, we have deeply rooted local wisdom. These are time-tested, micro-level traditional methods tailored perfectly to their local environments. Think of diversion channels called ghouls or cools, built in the western Himalayas, or the brilliant rooftop rainwater harvesting systems used to capture every single precious drop in arid places like Rajasthan.
And the fascinating thing is, manipulating water is far from a new concept for us. Archaeological records show that way back in the 1st century BC, places like Sringavapura had incredibly sophisticated harvesting systems to channel the floodwaters of the river Ganga. From ancient stone rubble dams, lakes, and canals, right up to the modern era where we've dammed most of our major river basins, structural water conservation has always been an integral part of human survival.
Section 6, Securing Our Water Future. So the crucial point is how modern governance is attempting to marry these two approaches, synthesizing massive-scale distribution with micro-scale efficiency. We're seeing this right now through comprehensive multi-layered strategies. For instance, the Pradhan Mantri Krishi Sinchai Yojana aims to ensure protective irrigation access to all agricultural farms, driven by the slogan, "Water to every field." They're pushing hard for on-farm water efficiency, heavily promoting the concept of per drop, more crop, using targeted technologies. Alongside this, the Jal Jeevan Mission prioritizes dramatically improving rural life by ensuring safe, adequate drinking water reaches households directly. It's really a dual push to manage both the quantity and the quality of our water.
Because overexploitation has the power to cause a profound ecological crisis that will impact every single aspect of our lives. We have the engineering, we have the traditional wisdom, and we have the modern policies in place. The question we must ask ourselves now is this: will we continue to impoverish our most essential resource, or will we collectively change how we value every single drop? The clock is ticking toward 2025. Thanks for joining me for this explainer. Keep asking questions, and I'll catch you next time.